Hi, this is Eric Turner with EA Electro-Automatic. This video is going to give a short overview of the theory of operation of regenerative DC loads. First, let's go ahead and take a look at the technology behind regenerative loads.
So the theory of operation behind a regenerative DC load is much like a solar inverter. PV panels output DC. It goes through a grid synchronized AC current source, which then synchronizes to the localized grid and drives current back through the grid. The ELR load connection is very, very similar in that it brings the energy from the UUT in through a DC to DC converter. That DC to DC converter goes through the AC inverter mains grid synchronized power portion of the source, and then that energy is simply fed back onto the grid. Now, one of the things you'll notice here is basically it takes the AC from the diagram below, converts it to DC, and then returns about 95% of that energy back to the utility grid.
So what you can see here is we have one of EA's programmable DC power supplies, mated up with one of our ELR programmable loads. One of the things, we'll go ahead and start up the load. I've currently programmed about 80 volts, 37 amps. I'm right at around 3 kilowatts. So one of the things you might notice from the get-go is that there's very little dB noise actually coming out of the load. Because these regenerative loads are operating anywhere between 93 to 95% efficient, that means we're only actually burning up around 4 or 5% of that loaded energy in the form of heat. Well, instead of burning 100% of that through a traditional model, like maybe a ceramic load bank, or perhaps a electronic linear load where 100% of that energy is getting burned in the form of heat, here we're only burning around 5%. So one of the big benefits this has is simply for users, it's not as loud. This is about as loud as it gets right now, and we're pulling 3 kilowatts through this particular load. One of the other things you might notice is the size of the load. So this 3U chassis can house up to 15 kilowatts of load. Our newest generation, our ELR 10,000 series, will actually load up to 30 kilowatts in a 4U chassis. So regenerative DC loads are typically about 6 times more compact than a traditional linear load or even a wire-wound resistor load bank. One of the, obviously the biggest benefits that comes out of this is the cost savings that comes along with regenerative DC loads. You know, we've done studies where we've saved customers hundreds of thousands of dollars a year based on simply recovering that energy, putting it back onto the localized grid, and reducing the total cost of operation.